In this set of tutorials, we're going to make an interface for our mouse theremin. In our previous sets, we created in Super Collider a sine wave oscillator that's really controllable by these OSC messages. So I have this running now, and technically I have a sine wave oscillator running. It's going to create some sine wave tones, but in order to create that, I have to trigger it. I have to designate a pitch and an amplitude using the OSC messages. So I'm going to make an interface in processing. So let's get started with that. So I'm going to set up my basic things. I think in newer versions of processing, this might be done for you. Void setup. Most sketches have a void setup. And remember the curly brackets to declare the scope of setup, and then a void draw. And same thing, a scope. Now, very typically, we declare a size in setup. We use a size function. And let's make this 800 by 600. Okay, and oftentimes in draw, we make a background. In this case, let's just make it black. Okay, if I was to run that, I just get a black square there. All right, now, what I need to do is I need to send some messages from my processing sketch to Super Collider. We'll cover that in the actual OSC setup in the next tutorial, the lesson. But just to give you an idea, basically, I want to be able to click somewhere and then produce a pitch. And I'm deciding to make my horizontal the frequency or the highness and lowness of the pitch, kind of like a piano keyboard. And then the y-axis, the vertical axis, to be the amplitude. So higher will be a little bit louder, lower will be quieter. Okay. So in order for me to be able to do that, I'm going to need to track my mouse movements. So how do I do that? Well, as I mentioned in the previous tutorial on built-in functions, built-in variables, and functions and variables, there's a handy mouse X and a mouse Y. All right. So if we were just to print that, mouse X is always going to return the current location of my X location of my mouse. So we'll look down here for the printout, run that, and then you see it's changing depending on where I move my mouse. Now you notice here, what's going on here? Right, you notice here it doesn't change when I'm not on my sketch. So it only reports the mouse X when my mouse is actually touching my sketch. Okay, but in there, it's not reporting anything. All right, so there you go. We have a mouse X. Now, how do I translate that mouse X into something that's usable by my mouse theremin? Now, if you recall, if we can just review here, I am looking for a pitch argument. Remember these control rate arguments here? I'm looking for a pitch argument in terms of MIDI note numbers. And remember, 60 is middle C, and the MIDI notes are incremented linearly, or 1 is a half step. So 61 would be C sharp, 62 D, etc. All right. So let's do. So basically, I want to communicate in those terms. Now, if I was to just send it, if I was to send my Super Collider just the value here in mouse X, I would do something from 0, which is really, really low, to 800 basically, which is super, super, super high. That's, I don't know how many octaves, whatever, really, really high. Okay, so that doesn't do. So we have to scale our mouse X range. And so if I want to make it, say, about a 2-octave range, centered around 60. So let's just do some math here. If we have 60 is the midpoint, and then if we want 1 octave below 60, we can have we can have 48, and then 1 octave above 60 will be 72. Okay, so what we're going to do is map now our mouse X. We're going to use a map function. Okay, so this is the way this works now. Let's make a new sketch here. I'll just show you map, this isolated. So you have a function that's map. Okay, and then it's looking for a number of arguments in these parentheses. And it's going to map, the first argument is the number that is being mapped. So in this case, it'd be mouse X. Okay, and then it's the input range. So the mouse X is the width of our sketch. So it's 0 to, what is it, 800, right? Sorry, comma. That's the minimum input range, and that's a maximum input range. And then the map to range. So what do we want to map it to? Well, we decided it was going to be 48 to 72. There you go. So that's going to take this 0 to 800 range, and it's going to map it out to 48 to 72. Okay, so let's copy that, and let's pop that into our print. So we're just going to print that figure out. And I'll just put a space in so you can see where we don't need that semicolon anymore. You can see where it's coming from. I'm going to print this mapped value now. So you see 48 here, and also notice it's a floating point number. Okay, which is kind of nice. That means we can get pitches in between, unless, you know, if we want to, if we don't want to worry about tuning, there's some tricks that you can make it so you can't play out of tune, or, you know, out of tunes out of the semitones. So there you go, 48 at the very bottom, and the very top, we're kicking out, you know, almost 72. If you wanted to just sort of adjust it so we don't have to worry about those extremes, maybe we'll go for 47 to 73. That way we make sure to get 48 and 72. Okay, so that'll be our number. What I'm going to do is I'm going to assign a variable to that, and then update the variable in draw. So I'm going to say a float. Remember, the map gives you a float number, and I call this pitch. Okay, and then in draw, maybe just after background, I'm going to say pitch equals. So draw will update that's my dog there. There's a delivery man outside. Okay, draw will update. Draw will update here at the pitch line, and then we can just print line pitch. Das hush. So there we go. It's still the same. See, now we can really get 48 in, and then 72. Okay. So, and then I mentioned that we wanted to use our y-axis for amplitude. All right. And if you recall, in Super Collider, we're looking for an amplitude really between 0 and 1. All right. So let's do that. And we'll do something, we'll just pop it in here. Now you can declare variables in a row like this with the comma. So we go declare amp. And we'll just copy this, reuse that code, because we're going to map the amp from the mouse Y now, and then we're going to use mouse Y. That's this axis. Now remember, we're dealing with a different values here. We have 800 width, but we only have 600 height. Okay, so we're going to go from 0 to 600 in this case for the mouse Y. So mouse Y is going to be mapped from 0 to 600, and we actually have to flip it around. Intuitively, it seems like as we go up, it will be louder, right? But in fact, as the way the coordinate system goes, up is 0 and down, in fact, is 600. So at the bottom of our sketch, it will be 600. At the top of our sketch, it will be 0. So we can either flip these around, which might make more sense, or we can flip those around on the output. So let's flip these around. Let's go from 600, from 600 to 0. And we're going to go from 0 to 1. Okay. And then let's just print amp there. Let's see if that works. So that's 1 up here and 0 down there. Perfect. All right, so basically we have kind of a functional thing here. We have our mouse X and mouse Y being mapped to a desired pitch range and a desired amplitude range. All right, so we'll wrap that up. That's pretty much all we need to do there, setting up our basic sketch and then mapping those two. The next tutorial, we'll look at actually how to send this data through the network to our Super Collider sketch.